Alright, welcome everyone to the next lesson in this series, and in this video we will look at multiple IP pools with Calico. Now with the previous lessons, when we spun up our labs, we configured or defined a single IP pool in what is known as the installation resource that we use to deploy Calico in the cluster. Now when we deploy Calico with a single IP pool, pods in the cluster receive IP addresses from that pool. Now, in certain cases, you may have a requirement to define multiple IP pools in the cluster so that specific pods or workloads receive IP addresses from a specific IP pool. One of the most common reasons I've seen for this is it's possible that a subset of your pods may require routing in the underlay network, in which case you need to advertise those pod prefixes to an upstream router. In such cases, you may allocate IP addresses to those pods from a separate IP pool. But this could also be used in cases where you require tenant isolation, or maybe you have workloads for multiple customers deployed in the same cluster, in which case you may allocate IP addresses to those workloads from separate IP pools. So in this lesson, let's look at how you can configure or deploy Calico with multiple IP pools and annotate workloads so that they receive IP addresses from a specific IP pool. So let's get started. All right, so in this lab, we will deploy Calico with two IP pools. The first one is called the default IP pool, and typically workloads in the cluster will receive IP addresses from the default IP pool. In addition to the default, we will also configure an IP pool known as the secondary IP pool, and we will look at how we can annotate workloads so that they receive IP addresses from the secondary IP pool. Now, in my case, I have already deployed this lab. It can be found in the multi-IP pool folder in the container lab folder if you've cloned this repo. So, just as we typically would, we can check the topology of this. We're using the topology from the previous BGP labs. So you would see the kind nodes as well as the CEOS image that we use to peer to an upstream network. And in a subsequent lab, in a subsequent lesson, we will look at how these IP pools can be advertised to the upstream network. And that's why I'm using the same lab topology. Once you have the lab deployed, you can export the kubeconfig file that the deploy script spits out once the lab is provisioned. And once you've deployed or rather exported the kubeconfig file, you can verify that you have access to the cluster. As you can see, in this case, we have a 3-node kind cluster. Now, this lab is already deployed. And if you look at the Calico custom resource that the deploy script use to install Calico in this cluster, this is what that custom resource looks like. Okay, and as you can see, we have two IP pool definitions, right? So in this lab folder, if I go to cd calico cni config, right, I would see this YAML file, which is custom-resources.yaml. And in this file, we have what is known as the installation resource. And in the installation resource is essentially the config that we provide the Calico operator to bootstrap the Calico install in this cluster. And in this configuration, we have defined two IP pools, right? So the first one is called default IPv4 IP pool, and the second one is called secondary-IPv4 IP pool. Now, there is a difference in the definition of the two IP pools. Notably, if you look at the node selector here, in the secondary IP pool, the node selector is set to not all. And in the primary or the default IP pool, the node selector is set to all. So what this means is the secondary IP pool will not be used by Calico to assign IP addresses to pods unless specified in the workload definition in the form of an annotation. And we will look at that shortly. Okay. Now, an important point to note is that when you define IP pools such as this, you can see that the first IP pool has a side of 192.168.0.0.17, and the second IP pool has a side of 192.168.128.0.17. And both siders are within the 192.168.0.0.16 range, which is the pod cider range for this cluster. So if you look at the kind definition for the cluster, right, it can be found in the K01 no CNI YAML, which is the kind definition. We've defined the pod cider as 192.168.0.0.16. it is important when you are configuring or when you're splitting this range and defining multiple IP pools, it is important that those IP pool CIDRs are within the pod subnet range or the pod CIDR range, also known as the cluster CIDR range. I know this could be referred to in many different ways, but essentially this is the pod subnet that you defined as your clusters are provisioned, right? So make sure the IP blocks are within that range. Otherwise, you could have some issues with kubeproxy netting, okay? All right, so with this cluster deployed, what we can do is we can do a kubectl get IP pools. Like I mentioned, this is from the previous BGP lab, the topologies from the previous BGP lab. We have a load balance IP pool as well, which you can ignore. But for pods, we have a default IP pool and a secondary IP pool. Now, what you can do next is you can verify the block affinities in this cluster. And if you remember from one of the previous lessons, the block affinities are essentially how Calico carves out that IP pool into /26 blocks as defined in the IP pool and allocates individual blocks to nodes in the cluster so that as workloads are spun up in those nodes, they get an IP address from those blocks. Now, if you look at the block affinities and if you notice the subnets or the CIDR of these block affinities, they are all within the default IP pool. All right, so we have 192.168.69, 42, 88, ignore the load balancer affinity. But if you look at the pod IP pool affinities, they're all within the default CIDR range. And what this means is Calico hasn't assigned any affinities based on the secondary IP pool. And that's because none of the pods or workloads in this cluster have requested IP addresses from that secondary IP pool. Okay. Alrighty. So as a next step, what you can do is if you look at the pods in this cluster, we have two daemon sets. One is known as multi-tool 1 and the other one is known as multi-tool 2. And if you look at the IP addresses for these pods, they are all within the default IP pool range. Okay. And the easiest way to identify is that if you look at the third octet here, all of these are below 128. Okay. So anything above 128 based on the CIDR that's defined would be from the default IP pool, and anything above 128 in the third octet would be from the secondary IP pool. So next what we're going to do is we are going to annotate the multi-tool 2 daemon set so that it receives an IP address from the secondary IP pool. So this is the multi-tool 2 daemon set, right? So essentially what we're going to do is annotate that daemon set. All right. So let me go ahead and do a kubectl patch to annotate the daemon set. And once you annotate the daemon set, what you're going to notice is that the pods that belong to that daemon set will restart. So we can see that these pods just restarted. And if you look at their IP addresses right now, they are from the secondary IP pool. And you can tell that by the fact that the third octets, the value of the third octet are now above 128. Okay. All right. So let me come out of this. Now, if you look at the daemon set, this is the annotation that we specified. So if I do a kubectl get daemon set multi-tool -2 -o YAML, and this right here is the annotation that we applied to this daemon set. And what this annotation essentially specifies is that this is a Calico specific parameter, and it specifies the IP pool, and Calico sees this and then assigns IP addresses to these workloads from the secondary IP pool, all right, or any IP pool that's defined under this annotation. All right, so if I come out of that, what we can do next is, so we looked at the pod IPs, and in addition to the pod IPs, you could also look at the block affinities, and what you will notice is that now the workloads have block affinities from the secondary IP pool as well, right? So Calico has gone ahead and assigned those block affinities. Given that this is a daemon set, every node has received a block affinity, and the daemon set, individual pods from the daemon set have received IP addresses from within those blocks. Okay. All right. So that's how you can go about ensuring that certain workloads receive IP addresses from certain IP pools. And in the next lesson, we will look at how you can advertise an IP pool to the upstream network so that those pod IPs become first class citizens in your network and are routable in the network and can be directly connected to from other clients or workloads in the network. Okay, so that's it for this one. I hope you enjoyed this lesson. Thanks for watching. I'll see you in the next one. Bye for now.